Hello calculus friends, let's do some problems today that involve the graphing calculator. So everything we've done has been pretty much by hand. You may have been using the calculator to do some calculations, but our calculator has some really powerful features that can be really time saving. And I will tell you on the AP test, you'll have to be able to use the technology in the form of the graphing calculator in order to answer some of the questions. And we will practice those and continue to practice those as time goes on. So the first thing we're going to do is we're going to define a function. And we're just going to start with some examples. And I'm going to say my function is just 3x squared. I want to keep this really simple. And let's calculate f of 2. And we can certainly do that mentally. 2 squared is 4 times 3 is 12. Let's also calculate f of 5. And 5 squared is 25 times 3 is going to be 75. Okay, and that's great. And that's easy. And it's easy because the function was simple. And they're not always that simple. But I wanted to start with a simple function so that we would get used to using the calculator and get some confidence in terms of we already know the answer, and let's see how the calculator can help us do these things. So here's my graphing calculator. Yours may look a little bit different. You may have a TI-83. I'm going to go through different steps for different ones. This calculator can look like any of the calculators. So the first thing I want to do is, and the first thing our calculator can do is it can use function notation just like this. And that is really handy if this function is very complex. Maybe it's to the 4th power minus something to the 3rd. I want to figure out f of 2. Our calculator will do that for us. Now certainly you could just plug in the function in the calculating screen. By the way, this is the calculating screen where I can do things like 3 plus 3. That's when I say calculating screen, that's what I mean. But if I had to calculate multiple values, like 3 different values, our calculator can do that, and it would be a big time saver. So here's how our calculator can do function notation. First of all, let's put our function in. Function is 3x squared. Push enter. Donezo with that. Okay, if I want to calculate f of 2, I'm going to get back to a calculating screen. So I'm going to push second and quit to get back to that. And I need to find our function. Okay, our functions are located under this key right here called vars, which stands for variables. And I'm going to click on vars. And I'm going to go ahead and I'm going to arrow over to y variables. And I'm going to push enter. And specifically, I want it y sub 1 because that's where I plugged it in. All right, and from there, the calculator works exactly like function notation. I'm going to do parentheses 2. And this would be figuring out like f of 2 because I define the y sub 1 function to be the definition of f. Push enter, and you get 12. Okay, let's repeat that steps as we do this. So again, I would find my y function, which is under vars. I'm going to arrow over. I'm going to select y sub 1. And I'm going to push parentheses, and I would enter 5. And again, our calculator will do that for us. And I think you'd understand that's a big advantage if this function was complex and I had to calculate multiple values. If I just had to calculate one value, it might not be as big a deal. But oftentimes we're checking multiple values in this class, so that's one function where the calculator can save us some time. All right, the next one we're going to do is I'm going to use the same function, just so we don't have to redefine it, plus it's simple. And I want us to figure out f prime of negative 3, and I want us to figure out f prime of, I don't know, let's say 10. All right, let's do this by hand. We already know how to do this. So f prime of x would be 6x. So therefore, f prime of negative 3 is going to be negative 18. F prime of 10 is going to be 60. Okay, but again, our calculator can do this. It can calculate the derivative of functions at points. So we can do this right here. Our calculator cannot do this. Our calculator, again, cannot do this algebraically. What it can do is it can do it only at this point. So, I don't know. Now what's happening? Let's do this on our calculator. So I've got this in my y sub 1. That was the function I wanted. And I want to calculate f prime of negative 3. I'm going to scoot this over to do those steps. So I'm going to get to a calculating screen. I do that by pushing second mode, which will quit. Okay, we need to tell our calculator we're going to take a derivative. And the way I'm going to do that is I'm going to push math. And if I look down my list here, I have this one number 8 called n-deriv. There's two ways you can get to that. First of all, you could arrow down until you get to 8. Okay, I would do the shortcut. Here's the shortest way to get to the derivative. Push math and push number 8. Okay, now your calculator looks at a couple different ways possible. This is how most of your calculators work. If your calculator doesn't look like this, I'm going to go over a different way it might look later. So let's enter what we need. First of all, this is a derivative symbol. It tells us I'm taking the derivative. I'm taking it with respect to x. And then here's where I put my function in. We find our function by going to vars, arrowing over to our y sub 1, putting y sub 1 in there. And then this would be where I want to evaluate the function at. We said we wanted to find f prime of negative 3, so I would plug in negative 3, enter, and boom, our calculator can do that for us. Okay, let's repeat those steps again using f prime of 10. So I would do math 8. I'm always going to put x down here, and I'm going to do y sub 1. And then I'm going to do that at 10. And I'm going to push enter, and it is 60. I am going to tell you that, in general, you're not going to use your calculator when calculating derivatives. I think it's a good tool. It's a necessary tool for some problems we will have. But do not rely on the calculator doing this work for you. You need to be showing your work, doing the algebra, practicing those routines, because those are going to be necessary. There are going to be no calculator parts to the AP test, and there's going to be calculator parts. Okay, I was going to talk about if your calculator looks different than this. If you have a TI-83 Plus, your calculator looks different than this, and I'm going to go to classic mode on mine. And here's what I would do if I had that calculator. First of all, you'd still have your y sub the same, and the rest of that was the same as TI-84, plugging that in. I'm still going to do math and number 8. Okay, but your calculator just says n-deriv. Here's what you need to do. You need to put in the function. So I'm going to tell it what function I'm taking the derivative of, which is y sub 1, comma, which is above the 7 here. And then I'm going to tell it with what variable I'm taking the derivative with respect to, which is x, comma. And then we're going to tell it at what value. We were taking it at negative 3. Enter. Boom. There you go. All right, f of 10, let's go through those steps. So I'd push math, number 8. I need y sub 1, which is under vars, going over, click on that, comma, x, comma. I want to do it at 10, and we'd get 60 either way. So either calculator is going to be totally fine for this class, but that's how you use each one. So you're maybe asking yourself, like, why would we need to use the calculator? Let's do an example for that. So let's say, for example, I defined f of x to be tangent inverse of, I don't know, x over 3, and I want to know what's f prime of pi. No, let's say f prime of the square root of 3. Okay, do we have a way to do the derivative of an inverse? Now be careful, this is inverse, this is not tangent to the negative first. This is inverse. So we don't have a way to do this. And the reason the calculator is necessary is sometimes they give us functions where we cannot take the derivative using the techniques that we have. So let's go through how we would do this one. So I would put inverse tangent into y sub 1. The way I would push that is second tangent. I need to do x over 3, so I would do x divided by 3. Let's close that up. And let's get back to our calculating screen. Actually, let's push enter first. Then let's get back to our calculating screen. And let's do our derivative. I'm going to go back to math print mode, because I think most of our calculators probably look like that. And I'm going to do the derivative, which tells me I'm going to push math number 8. With respect to x, I'm going to use y sub 1. And I'm going to do it at the square root of 3. So I would push second, get my square root of 3. Let's do an enter, and I would get 0.25. And it's not always that nice of a number. Let's do f prime of 1. And let's see what we get for that. So again, that allows us to repeat our steps again. Math 8. I'm plugging in x here, y sub 1. And if I plug in a 1, I get like a long number there. It looks like it's about 0.3. So it'll be about 0.3. I'm going to tell you in general, we will round in this class. Oops, and I was off the screen there. I apologize for that. When we will round to 3 decimal places always in this class, and we'll practice doing that. So there it is, the derivative on the calculator, in addition to that function notation on the calculator. So what do you need to be able to do? Use function notation to be able to calculate function or different values of functions, calculate the value of derivatives at different values of the function. All right, that's all for that part.